Okay. Um, Number one, we want to determine if these sequences are arithmetic, geometric, or neither. Um, so remember, arithmetic means we add the same amount each time. Geometric means we multiply by the same amount each time. We want to write a formula for the sequence. Okay, so for A, we take a look at it, and we start at 15. So we could do this either way. We either add, let's see, from 15 to 45, we'd add 30. And then if we add 30 again, do we get, no. We'd have to have an 80 here. Okay, so we can tell already it's not arithmetic because we're adding and it doesn't work. So maybe it's geometric. Let's see. So to get from 15 to 45, we times by 3. And to get from 45 to 135, hey, we times by 3 again. And to get from 135 to 4, hey, we times by 3 again. And we could keep going. So we times by 3 every time. Now the hard part is coming up with a formula. Now let's think of this as being a function where we've got input and output. And the easiest way to do a sequence like this is to think of the output, the sequence as being the output. So that'd be 15, 45, 135, 405, etc. Now our input, it's usually easiest if we start with 0. So just go 0, 1, 2, 3. Okay, now think about what's a different way of writing this. And this will always be the case with geometric sequences, is the 15 can be written as 15 times our multiplier to the power of the input, to the 0 power. And here, it's going to be 15 times 3 to the first, because 3 to the first is just 3, so 15 times 3 is 45. And here, it's going to be 15. Now, we could write times 3 times 3, but we know the shortcut way to do that is 3 squared. Okay, and now, again, 405, the pattern continues. 15 times 3 to the third. So now you should be able to see if our input is n, our output will be 15 times 3 to the n. So our formula is 15 times 3 to whatever letter we want. I just like using n for when you got sequences. If you want to use x, that's cool. If you want to use A, that's cool. If you want to use a little smiley face, that's fine too. Okay, now some of you may have noticed, hey, there's a shortcut way to do this. All you have to do is, this number is the initial, is the first value, the first one in the sequence, and then this number here is the multiplier. So there's kind of a shortcut way to do that one too. So, all right, so let's take a look at this next one. 5 to 20, let's see, we can times by 4, but then if we times that by 4, we would need an 80 right here, which we don't have. So this one's not geometric, because there's no multiplier that fits. Let's see, we could try adding. 5 to 20 would be add 15, and then if we add 15 again, we'd have to be at 35. Well, it's not working, right? That's all we have to check. If it's not consistent the whole time, then it's neither. Okay, let's take a look at the part C. It goes from 3 to 10 to 17, blah, blah, blah. Okay, like that. You can just kind of look at it and say, hey, look at this. If you add 7, and then add 7 again. Oh, we forgot to write that this one is geometric. Geometric. Okay. I'm going to turn the exposure down a little bit so it's not as bright. Okay. Hey, but back to this. Add 7 again. Add 7 each time. Okay. So again, this one is arithmetic. But the hard part is coming out with the a formula for it. So again, let's make it n and out table and think of it as being, all right, so the input, again, it's easiest if we start with 0. 0, 1, 2, 3, 4, etc. And then the output is the list in the sequence. So we got 3, 7, oh, I'm sorry. That's 3, 10, 17, 24, 31, etc. So what's another way of writing this? Well, again, this is our initial value plus what we're adding each time. So in this case, it's 3, well, it's just 3, but it's really 7 times our input, 0. And on the next one, it's 3 plus 7 times our input. And on the next one, it's going to be 3 plus 7 times our input, which in this case is 2. And this works every time. So, in fact, now here, let me erase this one so I have some room. So on our nth input, our output is going to be 3 plus 7 times n. So our formula is 3, let me write that up here, 3 plus 7n. And again, a lot of people I think have noticed that there's kind of a shortcut way to do this, that this is like the first value, the initial value, and this number here is what we add each time. And this, no, not the n, sorry, the number in front of the n, is what we add each time. And that's also known as the slope, if we're looking at an equation, or it's the rate of change. All right, so now let's look at number 2. Number 2, someone pointed out to me, kind of a typo. You decide to save money for 10 days, and then later it asks how much money you have on the 20th day. So this should be a 20. You decide to save money for 20 days. You decide to put a penny the first day and double amount the second day. Okay, now some of you might just be like, hey, this is doubling every time, so our formula is just 2 to the n, and so, well, but you got to slow down. I like to always make a little chart first, and we'll put the day and the amount of money we got, or the number of pennies. On day 1, we've got 1 penny. On day 2, we're doubling that to 2 pennies. On day 3, double it again, 4. On day 4, we've got 8. On day 5, we've got 16. Okay, so we got 16 cents on the 5th day. But 2 to the 5th equals 32. So really, what we're doing here is because we're not starting on what we'd call day 0. So we got to be careful here. So as we continue our graph, the total money, we need to figure this out. So on day 20, we save, now it'll be 2 to the 19th power. Okay, so you might have to think about that, maybe figure out the whole graph, but really the only reason is because we're not starting on day 0, because you don't really say day 0. So the 20th day is actually the 19th day that we've doubled it. So the total then is going to be given by, well, we've shown that when you double something every time, to find the total is 2 to the n plus 1 minus 1. So in this case, it'll be 2 to the, not 20, 2 to the n plus 1 minus 1. So in this case, it will be 2 to the 20th minus 1, which equals, if we use a calculator, a big number. So that's how you do that one. All right, let's look at this third one. I think most people got this right. What shape will be in the 88th position? So what you got to do is, we got this repeating pattern: square, square, smiley, 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 cross, diamond, diamond, square, square, smiley, smiley, smiley. Okay, so it starts to repeat after this one. And so we know there's 9 in there. So what a lot of people did is they went, all right, so we got 9, and it's going to keep going. So one way to think of this is if you go 88 divided by 9, we get 9 and, let me grab a calculator. It's going to be some weird decimal. Okay, we get 9.7777. And so what does this mean? Well, it means, so if we go along, think about if we had 81 divided by 9, that would give us 9 exactly. So that means our 81st figure would be here. That means I'm going to erase this for now. Our 82nd figure would be here, 83rd would be here, 84th, 85th, 86th, 87th, 88th, 89th, 90th would be there, and then we'd start repeating. So 88th position right here, we got the little cross thingy deal. Okay, here's another way to do this is 9.777 repeating, where our calculator will convert that into a fraction if we want. Right, and these ones will actually do it. If you go hit, where's math? Math, go into a fraction, 88.9. Oh, yeah, no. Okay. No, that didn't really help. Okay. But anyway, this is the same as having this is 9 remainder 7. That's what I wanted. I wanted it to show that this is 9 and 7/9. And so what you can do is just use this as being 1. Since the remainder is 7, it'll be the 7th one, because we'd have a 7 left over. 1, 2, 3, 4, 5, 6, 7. Yeah, so it's that one again. So that's another way to do that, is if you figure out the remainder, then you can just do that. And yeah, I hope that helped. And